Hello, this is Scott. Welcome back to my YouTube channel where I cover a variety of different data science, analytics topics, everything from open discussions to demonstrations of open source software like R and Python, and then commercial platforms as well. Today I'm talking about a commercial platform for visualization. It's called Spotfire, and the data that I'm going to use is some social determinants of health data. So we can look at people's behaviors and then diseases or the health of different people based upon those behaviors, and that's what social determinants of health is about. You can see here that I just typed into Bing social determinants of health, and these are some of the categories that pop up. But we're going to talk about diabetes, and so within Spotfire, what I have is I've got this data set. This data set is by county. We looked at this last time. And so each row is a county in the U.S., and I've got states, and then I've got an average determination of the behaviors for this. So last time we looked at the relationships, we looked at a simple scatter diagram, and we can look at, let's say, diabetes and how exercise or no exercise is related to diabetes. So what if we want to quantify that? Actually look at the strength of the relationships. Well, we can do regression, and so this is not a deep dive into regression. I just want to show you how to do this, and I will talk a little bit about some of the diagnostics and everything and regression in general. But if I go to tools and then I go to regression modeling, and I can do this, and I can say social determinants of health, and then I can make comments, etc. I can do a linear regression or a regression tree, like a partition or a cart model. And then I can look at data table is the current table that I'm using, but if I had multiple tables, I could select my table there. My response is I want to respond if somebody has diabetes. And the things I'm interested in is I'm looking at if exercise or lack of exercise, I should say, and obesity play a factor in that. So I've selected these. I need to click the add button down here to actually pull them in. So you can see this would be somewhat similar to R, right? So Y is we're regressing Y on no exercise and obesity, a linear model. And then if I select OK, what happens is Spotfire will open up a second pane and create a lot of output for me, and then also create some options. So if I just want to look at the relationships, this is one way that I can do it. I'm just going to cover this panel in this video, and then I'll create some more. But for this panel, I can see that diabetes is modeled by no exercise and obesity, and I can look at the standard error, the R squared. So R squared is how well our model fits, and adjusted R squared. So adjusted R squared, 34%. This is bounded by 0 and 1. Closer to 1, the stronger the relationship. But for two predictors and this simple data, that's not bad. Certainly it is related, both obesity and no exercise or lack of exercise. Looking at the individual coefficients, the statistical test on these coefficients, I can see that the estimates, the betas, right? So 0.19 for obesity and 0.11 for no exercise. And the test statistic, the t-value, and then the actual p-value, right? The test of significance. And so without getting too deep into that, that's the probability that the null is true, which is very low for no exercise. It's very low for obesity. So we would reject the null, and we would say that no exercise contributes to the model statistically, as well as obesity. Interestingly enough, if we test at 0.05, which is typical, the intercept is not significant. So that's very interesting. That means that we don't have, the intercept is not meaningful, and we can just use these two variables to predict diabetes. Looking real quick at some of the diagnostics, we're given the variable importance here. So the variable importance, obesity, is the stronger of the two predictors to predict diabetes, and then no exercise. I can look at other values as well. Here's a whole variety of basically diagnostics, which means that we can test the assumptions of the statistical model. Here, fitted residuals versus fitted. So this is normally used to determine if maybe the relationship is nonlinear, if it, these residuals cloud into like a bowl or an inverted bowl, then that might suggest that it's nonlinear. If they spike from one side, the spread is very low and it spreads out really high on another end, that violates one of our assumptions for constant variance across the models. Note that all these, one thing that's really misunderstood about statistics is all of these assumptions don't have anything to do with generating the model. You can generate the model just fine without these assumptions. It's when you want to do statistical tests like this t-value up here and determine whether the coefficient is statistically significant, then you have to have these assumptions of the residuals are normal, the residuals are constant variance, they're independently and identically distributed, things like that. So these diagnostics are for testing the statistics, not for generating the model. All right, so we looked at residuals versus fitted. We can look at the normal quantile plot. This is, again, the normality assumption, right? So we can test that if we want. We could also test scale location, which is also a way to quickly look at the heteroscedasticity or whether there's constant variance. And it's interesting, you're seeing what's happening. One of the benefits of Spotfire is you can pull up a panel and see how it cascades in on the other panels. In fact, I'm just going to drop this, and we'll look at the Cook's distance as well. So Cook's distance, general rule of thumb, these are for high leverage points. In other words, what points really might pull the regression line in one way or another. And the general rule is if you have 3 times the mean for any one of these observations, you might want to consider looking deeply into that. There are some other measures, but that's the simple one is 3 times the mean. So, for example, I might want to look at this particular point. I can see here it has a high Cook's distance. If I look at the panel right above it, right? So this one right here, this is the observation. I can see that it's out there as well, and it's way up here in the normal quantile range. So you can see how all of those statistics run together. And then a couple more that we might want to look at. Let me just drop this, and then I'll just close this out and pull this one up, and then I can see the response versus a fitted. And this is essentially how tightly my model goes. If I had a perfect model, perfect relationship with an just R square of 1, I would see this thing run up in a single line. And then lastly is the variable of importance, which we looked at. Hopefully this was meaningful, and I'll do a couple more. I'm going to do actually several on Spotfire, but I'm going to do a couple more on regression specifically. I want to separate them so that you can pick and choose what you want. I hope to see you again. Thanks.